The question we are going to see now is under conic section, but please don't forget to subscribe to the channel. You can first pause and then go through it. We did conic section as a topic. There are parabolas, ellipses, and then hyperbolas. So you can go through the playlist and then you see those videos in details. But now specifically here, we are handling that one of an ellipse. The question says, the line that is a tangent to this ellipse, obtain an expression for C in terms of this A, B, and M. Calculate the gradients of the tangents to the ellipse through the points, these ones. So this is our ellipse we have in simple terms. What do we know? The tangent meets an ellipse, which is a curve in this situation, at a point. So meaning at this value of y should satisfy that. But now to handle that, we always first remove these two denominators by getting the LCM. So it's that the LCM of these two is, by getting the LCM of this, we multiply this times this, then times this, which is over 1. So LCM is a squared, b squared. Then we multiply it here, the LCM here, here, and here. Set out. So when I get this LCM and I multiply it here, I'll have now b squared, x squared, plus this LCM I multiply it here, I get a squared, y squared. And I multiply it here, I get a squared, b squared. But now because this line is the tangent to this, means that now this value of y should satisfy that in that question. So now when I have my y equaling to mx plus c, then we just substitute there. So b squared, x squared. Now this y equaling to b squared. Then we form a quadratic in terms of x. Then we have to first expand this one, have b squared. When I expand this, I get this and this, then by 2 m c x. Then we square this equally b squared. Then we form our quadratic. So when I open brackets, now I have b squared, then plus a squared, m squared, the whole of this into x squared, then plus this times this, I have 2 mc a squared x, then plus a squared c squared minus a squared b squared equaling 0. When I bring this side, this a times this, I get this, then I bring this the other side. Now is that if we compare with a, I'm going to compare now with the general quadratic equation, but I'm going to use capital letters because we have small s there. So a x squared plus bx plus c equaling 0. So if we compare, can establish that my a there is this, then my b is coefficient of x, then my c is going to be, so we know that because this is a tangent, we know that for tangents always b squared is equaling to 4ac. So now I just substitute. My b is there, so I have 2 the whole squared equaling 4 into my a, then into my c, then when we square this we get our 4 m squared c squared a power 4 equaling to this 4 into, now we open brackets, this times this, I get this times this, I get b squared a squared c squared minus a squared b power 4, then this times this plus a power 4 m squared c squared then this times this, I get minus a power 4 m squared b squared. Now we see that this one is going to cancel like that. Now you can also see, okay, that now I can able have m squared c squared a power 4 equaling to b squared so now you can see that this one is the same as this a squared, I mean a power 4 m squared c squared, so meaning the whole of this is going to cancel with this. So this side I have 0. So now my 0 is equaling to, now you see b squared minus b power 4 a power 4 m squared b squared. Now you can able see that if I divide through, you see that our a squared is common, we divide through by a squared. If I divide here by a squared, what else is common? B squared is common. What else is common? Those are the only things common. So I divide them here. B squared. So see, I'll be having 0 equaling to my a squared goes, this one goes here, remain with 2. This one here remain with 2. This one goes. So I have c squared minus, here remain with b squared, then minus a squared m squared, which when I arrange, I have c squared, then I take this side, have a squared m squared plus b squared. But I want me to express c in terms of a, b, and m. So now we get a square root there. So if I get a square root, my c will be the square root of plus b squared, and that was how we had to handle our part A. Now part B, they are telling us that calculate the tangents, calculate the gradients of the tangents to the ellipse through the point. Now this gradient, this tangent passes through this point. So through a point, root s squared plus b squared, comma 0. Meaning that this is our x coordinate, this is our y coordinate. But which tangent is passing there? Our tangent is y is equal to mx plus c. Now from there, what do? You see that our y is 0 from here. This is 0 equal to the gradient I want. Then the x is root a squared plus b squared. Then plus c. But our c here is the root of a squared m squared plus b squared. When I take, so you can able see that that's what we have there. That is our c. Now our task is to get this m here. This was our x, and so now to get our m, we can start by taking one this side. When I take this side, I have now minus m root a squared plus b squared equaling to root a squared m squared plus b squared. If we square both sides, I square this side to remove that square root. So if we square both sides, now I'll be having, this will be now m squared into, now this root will go with a squared plus b squared equaling to, when I square this, when I cancel the square root, I have a squared m squared plus b squared. When we open brackets, you can able see here we'll be having m squared a squared plus m squared b squared equal to a squared m squared plus b squared. What do you see? You can see that this cancels with this because they are the same. So I'll be having now m squared b squared equal to b squared divided through by b squared. My m squared will be 1. Take the square root. So the square root this side, then the square root this side. So my m will be plus or minus 1. So that is the gradient. I mean, those are the gradients of the two. So you can able see they wanted us to calculate the gradients of the tangents to the ellipse. So the gradients are 2. So therefore, we come here and we come that therefore our m is 1 and our m is going to be negative 1. So those are the two gradients they wanted us to get, and so that's where we end with that question. So that's how we handle that question, members. They asked for the equations now of the tangents. You'll be having this m. They will be now giving you the values of a here and the values of b. You have m. You can able now get this c. So we'll have m now from here. We'll be having the c. Then you have the m, you have the c. We'll be having those two tangents. That's it, members. I wish you well. Some people here they put a plus or minus because we are getting the square root of yes. See you, but please don't forget to subscribe to the channel for more and visit the playlists there.